Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology under LJ University. Now we have been learning the combinational logic we started with adder and subtractor, that is the half adder, full adder, half subtractor and full subtractor. After that we learn about the code conversion. After that we also learn about the parity checker, generator. Along with that we have a magnitude comparator. Now this is like it's a kind of basket where we incorporate all the kind of different logics, where all the blocks, all the modules we are going to use, or it's already being used in our communication systems. One more term is the fundamental module that we define as the multiplexer, demultiplexer, decoder and encoder. Now multiplexer is like, you have a multiple inputs but the output is always one. That is based on the user selections. So everywhere, see, if you operate your television system and you are operating your television system with the help of remote control, where there are various channels are coming in your television, right? But through remote control you can see, you can watch a particular channel. So your remote control becomes your multiplexer, right? So here we are going to design about the multiplexer, and that is a digital multiplexer, and there are various multiplexers that we are going to discuss here. So multiplexer is again a part of the combinational circuit, combinational design, where the multiplexer is a special type of combinational circuit. There are n number of inputs and a single output having the selection lines of m. So in a digital circuit which selects one of the n data inputs and route it to the output, so its multiplexer is just the kind of channel selections, and selection of one of the n inputs is done by selected output. So you can see this particular block diagram having n number of input lines and having these selection lines. So that is 2 raised to m cross 1. So output is always 1. So here, based on this selection line, if I want to select the specific input, I can select like that way. So here you can see the y is, let's say, connected with the d0 with the selection line of 0 0 0. If it is a n cross 1, that means if it is a 8 cross 1 multiplexer where 8 number of inputs but the selection lines are 3, like that way. So here we have to design the multiplexer, and there are various types of multiplexer you can design, like 2 cross 1, 4 cross 1, 8 cross 1 and 16 cross 1. So from that, let's say first design 2 cross 1 is a pure fundamental where there are two channels A0 and A1 with the enable pin of E. So if you consider the enable pin 1, then and then further multiplexer will get the signal to make it on. And from this selection line is always 1 because it's a 2 raised to 1, that is equal to 2. That means 2 here is the input line. So either A0 or A1 is 0. So either Y is connected with the A0 or Y is connected with the A1, and that is given by the selection line of S. So if S is equal to 0, let's say Y is connected with the A1. If S is equal to 0, let's say Y is connected with the A0. And if S is equal to 1, let's say Y is connected with the A1. So from that you can have a 2 cross 1 multiplexer, and that's so simple from the truth table. So our design is always simple, starting with the truth table, then go for a k-map, then deduce the boolean function, and finally you can have your digital circuit with the logic gates. So input is, selection line is 0, so output is y is a0 and 1 is like that way. So from that you can be able to find the from the k-map what should be the function of y. So that function of y is nothing but s with AB. So you will have a sequence of 0 0 0 1 1 1 and 1 0. So finally you can have this 2 cross 1 multiplexer. Normally we'll always discuss with the 4 cross 1 multiplexer where there are 4 input lines from A0 to A3. So A0, A1, A2 and A3, and since this is a 4 input line, so selection lines are 2, S0 and S1. So from that you can be able to have y is equal to A0, A1, A2 and A3. That is based on a selection line of 0 0 0 1 1 0 and 1 1. So from that you can have a kind of design of multiplexer from y is directly connected with A0. From that you'll have a complete function of y. See here the y is nothing but A0 is going to be selected when S0 and S1 both are complement of each other. Both are 0 0. So when S0 and S1 both are 0 0, then A0 would be selected. Same way here, S1 is 0 and S0 is 0, then A1 would be selected. Same way here, S1 is 1 and S0 is 0. See, the A2 is selected. So this A2 channel would be selected. And finally, both the S0 and S1 are 1 1. See, A3 would be selected. So from combination all this three, if you have a from, see, the Boolean function is directly from the truth table. Y could be 1 when all these corresponding selection lines make like 0 0 0 1 1 0 and 1 1. Based on that, you can see the complete Boolean function in form of Y, where A0 would be selected when there is 0 0 you are going to apply to selection line S0 and S1. And likewise, you can design this kind of 4 cross 1 multiplexer. From that, again, you can make it a 8 cross 1 multiplexer where the selection lines are 3. So from that, you can have a complete design of this 8 cross 1 multiplexer. So the here Y, let's say if I want to make it A, Y should be connected with the A0 channel. So for that, my function of Y is nothing but S2 dash into S1 dash into S0 dash into A0. By that way is going to select the channel A0. Let's say if I want to select the channel A7, that means I have to make my Y Boolean function is as S2, S1, S0 and A7. By that way is going to select it, right? So this is what a design of multiplexer, and almost in all fundamental design we are going to use this kind of multiplexer. Now our next part is the decoder. This decoder is nothing but the combinational circuit that has n number of inputs to a maximum of m, that is equal to n raised to n number of outputs. So now here the n number of inputs, the outputs are 2 raised to n, right? So if you are going to apply 3 inputs, the output becomes 8. If you apply 2 inputs, the output becomes 4. So naturally here we are going to use this kind of decoder is to decode some of the code, is to decode the kind of information. So decoder is identical to a demultiplexer without any data input. So of course we are not much putting into the demultiplexer part, but always you can always decode a kind of your input signal in some form of output signal. So it performs the operation such as exactly opposite to the decoder. So here you can design 2 cross 4 decoder, 3 cross 8 decoder, likewise 4 cross 16 decoder. So it's just n to 2 raised to n decoder you are normally going to have. That means n number of digital inputs you have and 2 raised to n number of digital outputs you have, right? So if we further design the 2 cross 4 decoder, see here there are 2 input lines with the enable pin of the complete chip, and you are going to have 4 number of outputs. So from that, if you are going to define this particular truth table where I make it E is equal to 1, see A0 and A1 both are 0 0, my corresponding output Y0 it becomes 1, right? So you can see this, if you are going to apply A0 and A1 0 0, that means the Y0 it's triggered, so it's a 1. So ultimately you are going to decode here, that means you are going to convert 2 bit of information into a 4 bit of information. How? Like A0 and A1 both are 0 0, so your output stream is like 0 0 0 and 1. So that means the Y0 becomes 1. If your input sequence is 0 and 1, right, so your Y1 it's triggered, so your output sequence is 0 0 1 0. You can see from this particular truth table, if your input is 1 0, so the output sequence is 0 1 0 0, and your input sequence is 1 1, your output is 1 0 0 0. So this is very much interesting where you have decoded from 2 input or from n number of bits to 2 raised to n number of bits, right? So that's and that particular design you can have Y0 is nothing but E into A0 dash into A1 dash. So if right now, let's say if you are not going to consider the enable pin, then the Y0 becomes A1 dash into A0 dash, Y1 becomes A1 dash into A0, Y2 becomes A1 into A0 dash, and Y3 is nothing but A1 into A0. So Y3 is corresponding to 1 1, so it's a 3 is a 1 1, Y2 is corresponding to 1 0, Y1 is corresponding to 0 1, and Y0 is corresponding to 0 0. So by that way, see, you can have a complete stream, and from that you can have and you can design a 3 cross 8 decoders by making 3 digital inputs and taking 8 digital outputs, right? So here, by using the 3 cross 8 decoder, see, you are going to decode 3 bits into a 8 bit of information, right? So from that, again, if you are going to remove the enable line, then you have a 3 inputs line of A0, A1 and A2, and you are going to convert the output lines is from Y0 to Y7, right? So if I'm going to apply 0 0 0 as part of the input, see, Y0 would be selected and Y0 will be 1. So my sequence, if I consider from MSB to LSB, it's 7 zeros and then 1, right? So that is what I'm going to convert 3 bit of information into a 8 bit of information, right? So this is what the job of decoder. So this is a kind of truth table where you can see, and forget about the enable pin right now. So from, you have a sequence of A2, A1 and A0. So first part is a 0 0 0 when enable pin is 1, and your corresponding output is all 7 zeros except y0 is 1, right? So by that way you can check the complete sequence as corresponding input bits is 0 0 1. See, y1 is triggered, 0 1 0 y2 is triggered, 0 1 1 y3 is triggered, likewise 1 0 0 y4 is triggered, 1 0 1 y5 is triggered, 1 1 0 y6 triggered, and 1 1 1 y7 is triggered. From that you have converted 3 bit into a 8 bit of information. So this is what about the 3 to 8 decoder. So normally all those kind of digital circuits we are using for a combinational purpose, where anytime you have to select a specific channel. For that you use the multiplexer. If you want to decode any part of the information, then the boolean function of y0 is always a2 dash, a1 dash and a0 dash. By that way you can have up to y7 is a0 into a1 into a2, right? So by that way, so this is what the boolean functions, and from that boolean function you can see the kind of digital circuits where y7 is nothing but a kind of ending function having some of the complement of a0, a1 and a2. So this particular combination circuit you can check only made up from the NOT gate and AND gate exclusively, right? So this is what about the 3 to 8 decoder. So by that way, so you can design multiplexer decoders, 4 cross 16 decoders. You can also construct by making 2 3 to 8 decoders by making the enable pin. One time it is 0, another time it is 1. Same way you can also make this 4 cross 16 decoder using the 2 cross 4 decoders, but you have to take 4 times. So this is what the complete design, and this is what the truth table of 4 cross 16 decoders. So here I'm going to convert 4 bit of information into a 16 bit of information. So by that way, all this particular boolean function you can observe from y0 to y15, and based on that you'll have a kind of digital circuits, right? So this is so much interesting of design the multiplexer and decoders. So what are the application of this decoder? So decoders are greatly used in application where the particular output of group of outputs to be activated only on the occurrence of specific combination of input labels. So very often this input labels are provided by the outputs of a register or counter that we are going to use it, right? Dear students, thank you very much. Now you would understand how you can design a multiplexer and decoder. Thank you.